Hello and welcome back to my channel. Students, as you all know, we are doing a problem series based on general organic chemistry. And in this topic, we have covered various subtopics like carbocations, carbene ions, aromaticity, resonating structures, acidity and basicity. So let us now try to see what is there for us in question number 26. So as you all can see, question number 26 on your screen, you have got three compounds A, B and C. Each compound has got a nitrogen, as you all can see, and you have to assess the basicity of the nitrogen in each compound, and then you have to put the basicity in decreasing order. So as I have already spoken a lot about how to decide the basicity, you should understand it is based on availability of electrons. More the availability of electrons, more will be its basicity. I have already told you to check the availability of electrons. If the lone pair remains in conjugation, and because of that conjugation, if the lone pair gets delocalized, in that case the availability decreases and therefore the basicity also decreases. And there were a few cases where we had seen that because of conjugation, because of resonance, number of lone pairs on nitrogen increased also, and in those cases the basicity increased. So now let us try to see case by case what is happening with A, B and C. Now we'll take up the case number A first. As you can see, this is our compound and the lone pair under investigation is not going to get delocalized. You should understand why it is not going to get delocalized, because the lone pair is not in conjugation with the pi system. Because you understand, this is lone pair, double, single. Now if it was lone pair, single, double, then there was a chance that lone pair may have got delocalized, but here the case is different. It is lone pair, double, single, so it's not going to get delocalized in that sense. Now coming on to what next we can have in this compound, there is a conjugation, as you all can see, double, single, double. This conjugation is going to work, and as you all know, the electrons shift towards more electronegative element. Now if you try to compare the elements, at this position you have carbon and at this position you have nitrogen. Nitrogen is more electronegative, so it's going to pull the pi electrons towards it, and on that ground you can say that this pi bond is going to shift in the resonance effect, and simultaneously these electrons are going to sit on nitrogen to create one more lone pair along with a minus formal charge. And because from this carbon the electrons are going away, it will acquire a positive charge. The same thing you can see in the below resonating structure. This carbon has got a carbocationic character now. The double bond is shifted to this new position, and the older double bond is now sitting on nitrogen in the form of one more lone pair bringing a minus charge. So what has happened basically, the original lone pair was not in conjugation, so it did not go to any place. It did not go to any other atom. It remains situated at nitrogen. Second of all, because of double, single, double, one more lone pair the nitrogen acquired, and in this resonating structure that is seen in a clear form. Now coming on to the case number B. Once you see the case number B and you realize that the lone pair on nitrogen is again not in conjugation. How? Lone pair, double, single. This is not the situation where this lone pair is going to go delocalize, go away. Okay. However, if you see the another possibility, you will find that there is another possibility of conjugation, double, single, double. And since at this position you have carbon, this position you have nitrogen, so shifting of electron pairs will be towards nitrogen. And if that happens, this pi bond will shift one place ahead and these pi electrons going to sit over nitrogen, bringing one more lone pair along with a minus formal charge. So now you can see the resonating structure. The carbon from where the electrons gone away gets a plus formal charge, a new pi bond as you all can see, and this nitrogen now gets one more lone pair through this resonance effect and a minus formal charge. So in both cases A and B, you saw that because of double, single, double alternation, the nitrogen is getting benefit of one lone pair, is getting one more lone pair. Okay, now I will compare finally which is going to get more benefit, where the resonance will take place with more tendency, that we will see in the final slide. Now coming on to the case number C. Now what happens in case number C, you should realize that again this lone pair is not in conjugation, so it will remain there. Next thing, there is another type of conjugation which is present in this compound, double, single, double. So on that ground you understand this is nitrogen and this is carbon, so electron will shift towards nitrogen in this manner. This pi bond will shift this way and this pi bond will sit on nitrogen to bring one more lone pair and a minus formal charge. And as you all can see, this carbon will get a plus charge because electrons have shifted away from it. A new pi bond is created and now this lone pair has got two lone pairs. Again, if you try to see whether this plus charge can further be delocalized or not, you find that yes, there is a possibility, because just in the neighborhood of this carbon bearing plus charge you have oxygen, a heteroatom bearing a lone pair, and this lone pair can be donated. As I have told you that this is again a situation where resonance can happen, delocalization can happen, and in such cases the lone pair shifts like this towards the carbon bearing plus charge, and as it goes away from oxygen, a plus charge comes on oxygen and just a single lone pair now remains on the oxygen, because one lone pair has gone to create a new pi bond, as you all can see. And since the electrons came towards this plus charge, a minus will come and plus and minus becomes zero. So zero formal charge comes on carbon. Now once you see these three structures and you realize that the final structure is a very special case, and this has a speciality, this is a special case because all atoms are octet completed. All atoms octet completed. Now this is a very important feature you have got. Now you can see the oxygen, how many electrons? 2 electrons from here, 2 from lone pair 4 to 6 and to 8. Similarly nitrogen also 2 to 4 to 6 and 1 nitrogen hydrogen bond, 2 electrons from there, 8. All atoms if you count will give you 8 electrons in that sense. So you understand here again the nitrogen is getting an extra lone pair, and another thing, the resonating structure you are getting after the nitrogen has got 2 lone pair, which is octet completed. So that is an extra stability factor remaining in the case C, that the resonance has given the nitrogen extra benefit of one lone pair, and apart from that, all atoms have octet completion. So it's the best structure till now we have read in the if we compare A, B and C. Now once you come to the case B, here you understand, although the nitrogen was getting two lone pair, but this carbon, the carbon bearing plus charge, has only 6 electrons, 2, 2, 4 and 2, 6. So its octet is incompleted. So although it is providing the nitrogen the lone pair, but sacrifice of what? Octet. One feature. Next feature is even important. As you get this ring, you should be very cautious. You should get alarmed. Why? Because this ring is not a simple one, but anti-aromatic ring. Anti-aromatic ring. And how? You can see that it's a cyclic portion. All carbon sp2 hybridized, and there is a cyclic conjugation which involves all the 5 atoms. How? Plus, single, double, single, double. So you can see all the 5 atoms are involved in cyclic conjugation. And how many electrons are involved? 2 from here and 2 from there. So altogether how many electrons? 2 plus 2, 4 pi electrons. And as you all know, if there is a ring which is planar, there is a cyclic conjugation, and number of electrons in the cyclic conjugation are 4, 8, 12, which follows 4n pi electrons rule. Then that ring is anti-aromatic in character, and it is a symbol of instability. So this is not stable and is a symbol of instability, and because of that, the donation of electrons to nitrogen, the extra lone pair coming on nitrogen is not that much feasible, because in doing so some anti-aromatic character is getting developed, which is not good for the health of that structure. So it will not happen with that tendency. If you come to the case A, here also you can find the electrons have shifted to nitrogen, giving two lone pair, and you have created a carbon with the plus charge, and this will have 6 electrons, 2 to 4 to 6. So octet is again incompleted, but this is a better carbocation in comparison to B, because in B you had anti-aromatic character. So in the case A also you have the carbocatonic character with incomplete octet. In the case B also you have the carbocatonic character with the incomplete octet, but B is not as good as A. Why? Because B has got anti-aromatic character, which is not a good symptom, which is not good for the health of this carbocation, is unstable. On the other hand, if you see the C option, C gives electron pair, one extra electron pair to nitrogen, and in this course it does resonance and makes a structure which is quite stable, and is quite stable on what ground? It is quite stable because here in doing so it gives an oxonium ion, a species where all the atoms have completed octet, no anti-aromaticity. So all the bad features which remained with A and B absent in C. So on this ground you can think that in the case C, the electrons will be provided to nitrogen through resonance in more tendency, with more inclination, because of the stability of structure. So after going through all the 3 cases individually, you come to a conclusion that the electron pairs are going towards nitrogen in all the 3 cases, but it goes with highest inclination, highest tendency in the case C. Then comes the case A, and it goes least in the case B because it creates anti-aromatic ring. So that is how you have to think how the the original lone pair on nitrogen was not in conjugation in any of A, B and C. However, because of alternate double single double arrangement, the electrons could be provided to nitrogen in the form of extra lone pair. And all the three cases, once we discussed, we found that in the case of A, you got a carbocationic intermediate. In B, again you got carbocationic intermediate, but the B had anti-aromatic character. So it is not a good sign. On the other hand, in the case of C, the carbocation finally converted into oxonium ion, where the lone pair from oxygen donated to the carbon bearing plus charge, giving you an octet completed structure. So on that ground you find that in the case of C, the nitrogen is most prosperous in terms of electrons, and in the case B, it is least available. The electrons are least available because the electrons could not be given with that tendency because of anti-aromatic character. So I hope you all must have understood the fine details I was trying to convey through this problem. Hope you all are watching my previous videos also. Lots of information, fundamentals you will obtain watching my videos. And do watch my videos in future also. I will try to bring more and more technical problem, logical problem, conceptual problem in near future. Till then, take a good care of your health and happiness. Thank you very much.